My name is George Costandi, and I'm the moderator today. Thank you so much for joining us for this very exciting webinar titled Rise of the Machines, Appliance Fires, and Flood Claims. So just a few pointers. If you've joined us through the computer to see the slides, you'll notice in the GoToWebinar console on the top right of your webinar screen, you could submit questions, and we encourage you to submit questions throughout the presentation. We'll try to get to as many questions as possible, and depending on how much time we have left over at the end of the presentation. If we don't get to your question in the webinar, we promise to follow up with you after the fact to make sure your questions are answered. For support or questions, you can email us at webinar@origin-and-cause.com. Your questions and your identity will only be seen by me, and I'll read them out and keep all identities confidential. Notice the icons on the bottom left of your screen, that lightning bolt and the moving mechanical parts. They're there on each slide to let you know what discipline the content is relevant to. So the moving gears would be mechanical engineering, and the lightning bolt would be electrical engineering. And of course, join in on the conversation on Twitter via hashtag #OCWebinar. I'd like to introduce you to our speakers. First, we have Michelle Bradley, who is a forensic engineer with over 10 years of experience. She specializes in mechanical engineering and does investigations such as product liability investigations, residential and commercial appliances, failure analysis, and vehicle fires, including truck and heavy equipment losses. Our second speaker is Mina Costandi. He's a forensic engineer with over 10 years of experience. He's completed over 600 fire and product liability investigations, and he specializes in electrical engineering. Types of investigations he does is electrical failures, product liability investigations, and residential and commercial fires. I'm going to pass on the microphone to Mina so that he can get started on fires and floods in the kitchen.
Thanks, George. Hello, everyone. So let's get started by doing a little poll to get warmed up. The question is, which kitchen appliance or category of appliances do you think is most frequently involved in fires? So you have a number of choices to make there. The poll will pop up on the screen in front of you, and you'll have the opportunity to cast your vote. You'll have about 10 seconds to do that. All right, everyone, wrapping up here. And we're done. So 51% of you said that the cooktop was the #1 appliance. Well, you're absolutely right. It's not just the cooktop, though. You'll come to find soon that the chef in the picture is actually also partly responsible as well. Some interesting stats here. Let's start off by talking about kitchen fires in general. 2 of every 10 kitchen residential fires, 2 of every 10 Canadian residential fires start in the kitchen. Fires happen in kitchens more than in any other place in the home. In Ontario alone, 18% of fires in kitchens are cooking fires. Increased appliance complexity nowadays in many cases means increased risk of fire. Innovations make appliances easier for us to use, but the complexity can also lead to other problems. There are more appliances or components that are now being manufactured abroad these days. Consumer Reports says that almost 4 of every 5 recalls involved products that were made outside of the US, with the majority coming from China. And a significant number of my files that I handle have something to do with the kitchen. So I'd like to explore various kitchen appliances with you today through a case study. All right, so we were called to a loss a while back that took place in a fire hall, believe it or not. The firefighters were doing chores around the fire hall one quiet afternoon, and they were called out to respond to an emergency at about 3 p.m. So after putting out the fire, they returned to the fire hall to find a fire in their own kitchen. One of the firefighters remembers cooking something before they got called out, but he was almost certain he had turned off the stove before he left. and no one else had noticed anything out of the ordinary that day. There was extensive damage to the property, and they had no idea what could have caused the fire, so we were called in to investigate the origin and the cause. So here's a photo of the kitchen. When walking through a scene, here's what I see as a trained expert. I immediately identify burn patterns, as you see outlined in yellow, and ignition sources in order to hone in on the cause of the fire. Here's another photo of the left side of the kitchen, not visible in the previous picture, which just shows another set of possible ignition sources. So let's walk through the appliances in this kitchen and explore how and why each one of these can possibly fail and start a fire. First, let's look at ranges. So 2 of every 3 cooking fires starts on the range cooktop, not in the oven or in any other cooking appliance. When comparing electric ranges versus gas ranges, surprisingly, they're equally likely to be involved in a fire. But the risk of fatality, though, increases 4 times with gas appliances because of the nature of the open flame involved in the burners, of course, and that can ignite curtains, loose clothing, robes, towels, etc., and because of the danger of gas leaks. Electric ranges, on the other hand, can be accidentally activated a lot easier than gas appliances, either by the user or by a defect in the controls. Many of the big brand names that many of us are aware of, like LG, Kenmore, Electrolux, have had their fair share of recalls. Here are a few examples of recalled electric ranges. So in this slide, you'll see several products that were recalled between 2009 and 2012. And all of these recalls had one thing in common. The digital controls in each of these models are defective. So moisture can actually get into the controls and causes the heating elements to behave in a funny way. Things like they can turn on spontaneously without actually being switched on by the user, or they can fail to turn off after the user has switched them off, or they can heat to different temperatures than what the user actually selects. And these malfunctions obviously have the potential of causing extensive damage if there's food or any combustibles sitting on the cooktop. Here's an interesting one. In May 21st, 2015, Viking gas ranges were recalled. It was reported that the ovens can actually turn on by themselves if liquid drips from the stovetop down into the oven. These failures are often discovered because of repeated insurance claims or online complaints, and we get involved in investigations alongside manufacturers, which can result in product recalls. So going back to our case study, we did a search on this particular range, and we didn't find any product recalls. We didn't see any evidence of failures. So next, we needed to consider user-related causes with the range. There are many variations of user-related problems that can cause fires with ranges, but the number one cause of range fires is unattended cooking, as you probably very well know. Another user-related cause of fire is the accidental activation of the cooktop. Cooktops with front controls are especially prone to this because they're so close to somebody's abdomen. If they are putting something away in the overhead cabinet, perhaps they can bump the controls with their abdomen. But not only are front controls an issue, rear controls can be as well. And here is an example of that. I was investigating a fire recently and found green plastic melted on the side of the range. I didn't know this till a bit later, but the fire department had found a larger piece of the same green plastic melted flat on top of the range before I even attended the scene. It was clear that something green, something plastic, was left on the cooktop. So after I looked around the home a bit, here's what I found. Green plastic bins that the homeowner uses for grocery shopping. So it turns out that the homeowner placed the box on the stovetop intending to put away the groceries and unintentionally bumped the controls to the on position. And they had rushed out of the home midway through putting away the groceries because they were late for their son's soccer game. And the rest is history. As you can see, it's the right color, It's even the right height to press up against the panel and accidentally activate the cooktop. Another user-related cause of range fires is ignition during the automatic self-clean cycle. Self-clean is a feature in many ranges that the user can turn on to clean the inside of the oven, and it works by cranking up the heat to above 800 degrees Fahrenheit. So that's pretty hot. Self-cleaning ignition scenarios often simply come down to people leaving combustible materials too close to or even inside the oven. These photos show what happened when someone set a bunch of scented candles on the smooth cooktop surface and turned on the self-clean right before leaving the house. And you wouldn't believe what I see people putting in their storage or warming drawers that are underneath the oven. Towels, cookbooks, oven mitts, even kids' toys. These can ignite during self-clean just because of the extreme heat. Or with gas rangers, they can even ignite during normal use. Also, I hate to tell you this, but sometimes we find mice living in ranges. Mice can nest inside the oven insulation, bringing in all sorts of ignitable things with them. They can bring in bits of dog food, French fries, etc., which can cause a fire if ignited during the self-cleaning process. Another user-related cause is arson. So sometimes that slam dunk cooking fire where the insured says that they forgot something on the stove and left it unattended turns out to be a not so innocent incident after some further investigation is done. When a range is used to stage a fire, certain clues may survive the fire. There have been cases of people placing combustible materials like towels, for example, draped over the cooktop as a mechanism to spread the fire beyond the range. Just a quick side note about subrogation. The golden rule is time is subro money. So when it comes to subrogation, time is of the essence. Get control of your scene and your evidence as quickly as possible. The subrogation process starts right here, and you can't afford to think otherwise. The more time that passes with evidence not being secured equals increased risk of compromised evidence, whether it's removed or altered, etc. And the more time that passes with evidence not being secured properly equals decreased negotiating power. I want to emphasize the importance of securing your evidence as fast as you can. When a loss takes place, one key factor you need to consider in administering the claim is that golden rule, time is subro money. Remember, with time that passes, your risk of compromised evidence goes up while your negotiating power goes down. But the moment you secure your evidence and you secure your subrogation potential. So the next claim that hits your desk, remember that golden rule, time is subro money. All right, let's get back to our case study. So after reviewing all the variables discussed about the range, none of them were actually relevant to this incident. So it was eliminated as a potential source of ignition. In fact, I hate to burn the case study a bit, but it was clear from the burn patterns that this whole side of the kitchen could actually be eliminated. But for the sake of the webinar, I'd like to speak about a few of these countertop appliances. Let's start with microwaves and blenders. When it comes to microwaves, there are two common causes of fire, improper usage and internal defects. Improper usage meaning overheating items unintentionally. Let's say somebody set something for 3 minutes, but actually keys in 30 by mistake and walks away, or 33, let's say, and walks away. Or microwaving dry or greasy foods because they ignite the quickest. For example, bacon or carrots, like who would have thought? The second common cause of fires in microwaves is internal defects, which includes circuit board failures. And you can see in the photo to the right, this is a photo of a circuit board that's commonly fails in microwaves called a filter board. It's mounted upside down in the photo. And when it comes to common causes of fires in blenders, well, there really isn't much to say. They don't commonly catch fire, perhaps for a couple of reasons. First, they aren't heat-producing appliances, and secondly, they're most commonly used for very short durations. All the recalls that I'm aware of online relating to blenders are actually for laceration hazards, not fire. But keep in mind, modern blenders do have circuit boards in them similar to microwaves and microprocessors as well as high-powered motors. So the potential for a defect is present, especially since they're exposed to liquids. So next, let's discuss coffee makers and kettles. During the 1990s, coffee maker fires became so common that arsonists started to take advantage of that and tampering with them to simulate well-publicized modes of ignition. So due to tightened safety regulations, coffee makers fires have become less common. But they still do fail nonetheless. Both coffee makers and kettles can overheat if their internal safety devices malfunction and they do not shut off as intended. This photo is an example of such a failure. But as I mentioned before, the burn patterns and physical evidence didn't support any of the appliances we just went through being relevant sources of ignition. So I continued my investigation, working towards the area of greatest damage, which I've circled for you on the slide. So there were 3 appliances that were of interest to me: the refrigerator, the dishwasher, and the toaster. Let's talk refrigerators. People don't normally think of fridges as posing much of a fire danger, perhaps because they're cold, but they do have heaters and they do draw plenty of current. And unlike ranges, fridges are constructed with a lot more combustible materials, plastics, which can provide fuel in the event of a fire. A common defect in fridges is a relay failure. A relay is just an electrical component which turns on the fridge's compressor. So you can see the relay there, and the compressor is that big giant component beside it, and the compressor just circulates a coolant fluid through the fridge to suck that heat out of the foods. The relay can overheat due to an electrical phenomenon called arc tracking, which ignites the surrounding plastics. So going back to the case study, the fridge didn't really exhibit any signs of a relay failure or any other type of failure common to fridges or freezers. So I eliminated it as a possible ignition source. The area of origin is now very clear, and we're on hot pursuit of the cause of this damage. So I proceeded to look at the dishwasher. The most common causes of dishwasher fires are the ingress or infiltration of water, or detergent and rinse aid. Also overheating of the heating element. The photos you see here are an example of infiltration of water onto a circuit board, causing ignition of the surrounding plastics. The photos you see on this slide resulted from a failure of the heating element, which is located at the bottom of the dishwasher. And this results in the ignition of the plastic tub. This particular appliance was actually recalled, but the insured had no idea. This type of failure can be especially destructive. As you can see in the photo, the dishwasher has pretty much disintegrated due to the extreme heat generated from the consuming of the plastic tub. So it goes without saying that stainless steel tubs are much more resilient. But neither of these dishwasher failures actually took place here. The dishwasher seemed to be unrelated to the incident. So that led me to take a closer look at the toaster. The 2 most common causes of toaster fires are user misuse and product defects. An example of user misuse is oversized or greasy or sugary foods that are heated to ignition, overheated so that they ignite, such as sugar-based pastries, for example. The most common manufacturer's defects in toasters is the failure of the switch that provides power to the heating elements. So this causes the toaster to basically stay on indefinitely, igniting the food that's in it or anything else in its path like curtains, paper towel rolls, low cabinets, etc. Circuit board components also have been known to fail and ignite on toasters as well. In this particular case, when completing a thorough investigation of the toaster with the manufacturer present, it was clear that the loss was caused by the failure of the switch that provides power to the heating elements. and this caused the ignition of the food and its surroundings. And there you have it, ladies and gentlemen. By determining the facts, conducting a scientific process of elimination, we discovered the truth behind this mysterious fire. So now we'll touch briefly on floods in the kitchen. I'll be honest, this isn't my area of expertise as an electrical engineer, so I'm going to pass through them quickly. My colleague Michelle Bradley will touch on them in greater detail later. This photo shows a fridge and dishwasher solenoid valve material deficiency. You can note that crack that the arrows point back to. This photo shows a water filtration system canister and how it cracked due to a manufacturing defect. This is a braided hose from under the sink, and it failed due to something called stress corrosion cracking. This is a water filtration system from under a sink, and in this case, cracks in the canister developed due to a manufacturing deficiency. Also, ice maker water supply lines can burst if, for example, an improper plastic tube is used. So this concludes my portion of the presentation. If you have any questions, please submit them now in the question box before you forget, and we'll address them later in the Q&A session. Or feel free to call me or email me at any time. Don't worry, I'm not as mean as I look in the photo. My contact info will also be listed at the end of the presentation as well. So please welcome Michelle Bradley.
Thanks, Mina. Could we have a round of applause for Mina's wonderful presentation? Woo! Hi, everyone. This is Michelle, and I'm going to talk to you about machines that can fail in the basement, causing fires and floods. First, let's talk about fires and floods in the laundry room. So let's talk about dryer fires. When a loss takes place, it is important that an expert attend the scene to determine if the fire started inside or outside the dryer and to document the scene. The fire shown in this photograph started inside the dryer. Just because it started in the dryer doesn't mean it's a slam dunk case. There is valuable information here in this room that has to be documented if you want a chance at subrogation. If the dryer is removed and sent to a contractor's for storage without having had the scene documented, you're decreasing your chances of subrogation. It's not impossible and it happens every day, but the best thing for you to do is to secure the scene. Don't move anything and call a forensic expert. We normally can have an investigator on site within 24 hours, and this will really help your subrogation case significantly. Okay, time for a quick pop quiz, everybody. I want to make sure you're all still awake. Where did the fire start? In this photograph, you can see that the washing machine is located on the left, the dryer is located on the right, and the third option is C, none of the above. Please cast your vote in the poll tool on your screen. Oh, I'm being told I have to keep talking while I was watching all your numbers. Okay, so would you say the numbers are in?
Yeah, so let's close it up.
Okay, so 66% of you said that the dryer was the cause of the fire, and the correct answer is in fact C. The fire didn't start inside the dryer. In this particular file, you'll see that there is more fire damage to the dryer than the washer, but the fire actually started in front of the dryer, not inside it. In this case, the adjuster did an awesome job of securing the scene for us to come in and take a look at the physical evidence. After the investigation was completed, it was determined that the fire did not start in the dryer at all. It was actually caused by the ignition of combustible materials in the laundry basket that was placed in front of the dryer after the load had been removed. If we didn't have the chance to examine the scene, we would have only been able to confirm that the fire started outside of the appliance, and that would have been it. So here's an example of a fire not related to a failure of the dryer. Sometimes the load will ignite through no fault of the dryer. If the dryer was in operation at the time of the fire discovery, keep the load of laundry being dried. It's really important for our investigation. We take a look at what was in the load. Sometimes there are things being dried that should never be in a dryer, like couch cushions, butane lighters, plastic tablecloths. I'm not kidding. I've seen all of these things firsthand. That missing couch cushion in the left photograph was being dried. I was only asked to examine the dryer and not the scene. I couldn't explain how the load ignited because I didn't have it to look at. The load was not retained with the dryer, and the scene was under repair by the time we received the assignment. These photos were given to me by the contractor, and look, the burned cushion was being dried at the time of the fire. Having the load of laundry available for review is extremely beneficial for the investigation, which ultimately helps you and your claim. Another cause of dryer fires is due to the improper installation of the exhaust. The exhaust's job is to expel moisture from the dryer. In this particular incident, the red outline shows where the dryer was installed, and the fire patterns on the two walls visible in the photograph tell us that the fire started in this corner. The yellow circle is where the exhaust exits the home. As you can see, there was a very short distance of about 12 to 18 inches between the back of the dryer to this exit location, as seen by the orange squiggly line. So the installer should have only installed up to 2 or 3 feet of exhaust. Let's look at the next slide. You're going to love this. These remains of the exhaust ductwork are 10 feet long and were all shoved in between the dryer and the walls instead of being trimmed to a usable length. This excess ductwork prevents correct airflow through the dryer, and in this particular case, contributed to a fire starting. There are obviously failures that occur inside a dryer that are related to manufacturing defects. Some failures I see include failures of the heating element, failures in the motor, high resistant connections, and I'll explain more on this in a minute, and electrical arcing events. These aren't all, these are just a few. Some of you might not have heard of a high resistance connection, so I'll explain a little here. When a wire connects to something else, either a part or another wire, where it connects has to be a tight fit. If it isn't, heat can be generated in this area that will eventually lead to a fire. Earlier, Mina mentioned heating elements in dishwashers. Here's an example of a failed heating element in a dryer. Do you see the break in the slinky looking coil? That is the heating element, and due to its failure, caused a fire in the dryer. These incidents are not uncommon and cause incredible amounts of damage. Okay, now let's talk about washing machines and their talent for causing millions of dollars worth of water damage. There's me with my brand new washer and my hat and my safety glasses. The 3 most common causes of water losses in washing machines are solenoid valve failures. Solenoid valves are water valves. Circuit board or control malfunctions, and hose failures. So let's talk about solenoid valves. This is a solenoid valve. The valve's job is to open when told to allow water into the washer. It is normally in the closed position and needs to be energized in order for it to open. The hose in the back of the washing machine is usually connected to the solenoid valve assembly. Sometimes we see that small bits of debris have gotten caught in the valve and do not allow it to close again. And that's when a flood situation takes place, because the valve isn't cutting off the water supply and the water just keeps flowing and flowing until you have a situation like this. So this is a water loss that took place in a beautiful multi-million-dollar cottage. The laundry room was located on the top floor of the home, which is extremely convenient when doing laundry, but not so convenient when your solenoid valve doesn't operate as it should. Solenoid valves also exist in kitchen appliances such as dishwashers and refrigerators. Their functions are the same, regardless of the appliance. They open to permit water into the appliance, then close to shut off water supply. There are many types of failures, such as the crack in the valve housing that Mina mentioned earlier. No matter the technical cause of failure, when solenoid valves do not operate as they were intended, it usually means trouble. Next, let's discuss circuit board and control malfunctions. This is a circuit board showing evidence of failure that caused an extremely large water loss. I'm seeing more and more of these types of failures because appliances are so high-tech these days. Circuit board failures can cause a fire, but we are seeing that these are also causing the appliance to malfunction and cause floods. A good example of circuit boards malfunctioning and causing floods is when people use too much detergent in a washing machine, which causes an overflow of bubbles into the housing of the washing machine. It won't seem like a big deal at the time, but those bubbles can come into contact with the circuit boards and cause future malfunctions. The third most common cause of washing machine water losses is hose failures. The type of hose in this photograph isn't typically recommended by manufacturers anymore, but they're still out there. Hose failures happen for many reasons, including, first of all, age. Studies show that failure rates increase dramatically in hoses over 5 years old. The failure of the materials themselves sometimes also participate in the failure of the hose. The reinforced rubber can crack, leak, or burst. Installation errors, such as not leaving enough slack in the line to prevent kinks or bends, and of course manufacturing defects. These types of losses usually involve a materials engineer who specializes in looking at the construction of the component to confirm the cause of its failure. You should see the sparkle in Dino Matei's eyes when he talks about hose failures. It's hilarious. He's our materials and metallurgical engineer, and he's in high demand. And so now we're going to talk about fires and floods in the basement, specifically involving sump pumps because of how often we see them. You would not believe how many people don't know they have a sump pump in their basement. I'd like to give you a quick anatomy lesson on sump pumps. These are the two most common styles of sump pumps, and yes, they look different, but they have the same parts and pieces. The purposes of these pumps is to remove water from the sump hole in the foundation of our homes and push the water through piping to the outdoors. They both have motors that turn the impeller, which is at the bottom of the pump, resting against the bottom of the sump pit. An impeller is like a propeller on a boat. It pushes water. Every sump pump has a power cord that plugs into a receptacle, just like a hairdryer, to get power. These power cords can get pinched, pulled, smashed, cut, and vacuumed over. All of these types of actions can lead to a failure of a power cord, which can result in a fire, not only on sump pumps, but on any appliance that has a power cord. So take your adjuster hat off for a minute and put on your homeowner hat and listen up. Protect your power cords. And if they're damaged, have them repaired by someone who knows how to do it properly. Sometimes the entire appliance needs to be replaced. Okay, adjuster hat back on, please. Here is an example of a failed power cord that someone tried unsuccessfully to repair. In the left photograph, you can see that there's a section of damaged power cord that had been covered with black electrical tape, and everything was okay for a couple of months. The photograph on the right shows the small arcing failure that was responsible for igniting a small fire that grew to cause over $100,000 worth of fire damage. When an electrical arcing failure occurs, the temperature of the molten metal is in the area of 3,000 degrees Fahrenheit and can take hours to drop to a safe temperature that won't ignite items. Let's talk about how the pumps work. As the water level rises in the sump hole where the pumps are installed, this causes the float to rise. The float is yellow in this illustration. As you can guess by its name, this is floating on the water surface. The red arrows show that the float and the rod it's attached to move up as the water level rises. The green arrow points to the float switch that activates in a way similar to when you flip a light switch in your home. It's on or it's off. The float and rod moving up cause the switch to go from off to on, just like a finger switching a light switch on. The pump begins to get rid of the water in the sump pit, which lowers the water level and moves the float and rod down. This causes the switch to flip off where it stays until the water level rises again. These switches can fail internally, either as a result of the way it was made or, with the style on the left, because it's been knocked by a puck or tennis ball during a heated game of basement hockey, which I've seen before. Sometimes the pumps will overheat and either stop working and allow a flood to occur, or overheat repeatedly and eventually ignite and start a fire in your home. One cause of an overheat scenario is when the impeller gets blocked and can't turn, even though the motor is trying to turn it. The impeller sits in the bottom of the sump hole and water is drawn into the base to be pumped outside. Items such as pebbles will clog the intake area and prevent the impeller from turning, which will lead to a failure of the pump, causing flooding and sometimes fire. The X-ray of the impeller on the left shows a clear impeller housing with no debris, whereas the X-ray on the right shows lots of little bits and pieces of debris, such as pebbles, that have been pulled into the impeller housing. These items will cause the impeller to be blocked and not turn, even though the water level's high and the float has switched the pump on. The pump ends up working hard to turn the impeller, but can't, so two things can happen: flooding or fire, and these are very costly claims. So now you know the anatomy of a sump pump and how they operate. I'd like to point out that sump pumps are unique in the sense that a lot of times they fail and cause water damage, but then continue to overheat and ignite. So one failure can lead to two perils, floods and fires. So ideally, sump pump failures lead to water damage claims and stop there. What I mean by saying ideally is water damage claims can cost a lot of money, but they don't take lives like fires can. The most common causes of sump pump failures that we see are power failures, tripped circuit breakers, or not having its own designated receptacle. For example, sometimes we see them plugged into a power bar or extension cord, which is a big no-no. Blocked impeller from debris in the sump hole, as mentioned before, and the sump pump not operating due to an internal failure. Specific component failures associated with sump pumps include float switches, thermal cutouts, welding in the closed position, overheating situations, eventually melting the lacquer coating on the motor windings, capacitor failures, blocked impellers, like we talked about earlier, and items falling on top of the motor of pedestal sump pumps. I know this slide is a little technical and dry, but I wanted to introduce these terms to you so you're aware of the different potential failure modes we look at when investigating sump pumps. The final appliance I'd like to touch on in the basement is furnaces. Furnaces are great when they're working, and boy, do we ever know when we walk into our homes at the end of a long workday in January to find that the temperature in our home is chilly. Again, with the hat transfer, please put on the homeowner hat again. The best way to prevent the failure of your home furnace and air conditioner is to have it inspected annually by a certified repair company. Typically, a good service person will be able to catch problems before they cause a catastrophic failure in this much relied upon piece of equipment in our homes. Not only will a furnace occasionally malfunction and cause a fire, but most newer models have a humidifier attached to it to provide moisture in our heated air. The last three failures I investigated that were related to a furnace failure involved flooding and not a fire. All three of these failures involved the lack of maintenance involving the humidifier, whereby the internal filter had never been changed because most people do not know it exists and therefore requires changing. And that concludes my portion of this webinar. I was addressing appliances in the laundry room and basement that contribute to fires and floods in the home. I appreciate all of you being with us today, and now George will take over.
Thanks, Michelle. Oh, that was great. Okay, so we're just going to go through a few questions. Thank you very much for submitting all these questions. It's great. So first, we'll start with a question for Mina. Do you find smooth top electric ranges more involved in losses of stuff set on top of them than old element style ranges?
Yeah, the answer to that is absolutely yes. In terms of just cooking fires and unattended cooking, no, there isn't. There's a good spread with both styles, but it's almost exclusively true that when you have the smooth top, people are much more likely to set stuff on there besides just pots and pans. Like one time people were moving in and they were putting away new dishes, so they set the cardboard box on the smooth top, and while leaning forward to put the dishes away, they had to leave suddenly, and the fire started. And sometimes these kind of fires are viewed as suspicious fires, and so you have to investigate it carefully. But yes, the answer is yes.
Great, thanks, Mina. Next, I have a question for Michelle. Are solenoid valve failures often found where there's hard water in the home?
Hi, that's a great question. With hard water, you will get bits and pieces of calcium and magnesium that can form crystals that will be found in a solenoid valve. A lot of people now who are in areas that have hard water are using water softeners that remove a lot of these minerals from our water, and it does make quite a big difference.
Great, thank you very much. A question for Mina. Don't you find the fire department causes the loss of evidence when they try to find the cause?
Well, yes and no. Some departments are very well trained in leaving evidence alone and preserving it and doing as little overhaul as possible. Some aren't. There's a few fire departments I can think of in my head now that like to pile stuff outside the window. So when that is the case, you want to make sure that your contractors are putting tarps on debris that's piled outside and preserving that and making sure that isn't discarded. We also, Origin and Cause as a company, we like to deal very closely with fire departments. Most of the fire departments that we deal with, we have a very good rapport with. So we're able to call them up and even have them come back out to the site and walk us through what were the observations of the crews, what they did during their investigation, what was moved, what was taken, etc. So we're able to work alongside with them to come to a conclusion as to the cause of the fire.
Great. Got a question for Michelle. Do submersible sump pumps suffer from overheating and fire?
Thanks, George. That's a great question. So, I'm going to be a bit evasive here. So it would depend on the circumstances, such as is the submersible pump actually completely submersed in water, in which case if you have a failure of the pump and it is submersed in water, that is going to assist with causing a failure of the pump only, which might lead to a flood, but not necessarily a fire. It would also, sometimes it will cause the items in the sump hole, such as the piping and the power cord, if those items can get ignited, they will often act as a wick, which will take the fire from the sump hole up into the rest of the building. Thank you.
Great, thank you. Mina, can you please provide a website that you can find the best product recall information on appliances of all types?
That's actually a great question. This is something that's I like to make my friends and family aware of. For our Canadian clients, the best way to get to this website, it's put up by the Government of Canada. You can just Google Canadian recalls, or if you want the actual address, it's healthycanadians.gc.ca. And the cool feature on that website is that you can actually subscribe to email alerts, and they come in daily so that you're kept abreast of what is malfunctioning and what is defective out there on the market. There's been a lot of cases where homeowners are totally unaware of the product recall because they weren't watching the news, because they didn't submit their product registration cards, or they moved into a house and inherited appliances which weren't registered. For our American clients, recalls.gov has got an excellent database of recalls. And I don't know if that one has a subscription. No, they do actually. I'm subscribed to both. So yes, you can subscribe to emails on the American site as well.
Great, thanks. Got a message or a question for Michelle. If too much detergent leads to electronic control failure, to me, that is a predictable cause of problems. So what are appliance manufacturers doing to prevent them?
Thanks, George. So a lot of people don't actually read their owner's manuals. And this is really helpful when you're determining, especially if you're getting a new appliance, it's really helpful in determining the little tricks of using that particular new appliance well. It isn't always like your old washing machine. For example, even with the high efficiency loads and the new products on the market, such as different detergents, there is often a much smaller amount of detergent being required, and People will often not realize this. And so let's say they've always used a quarter cup of soap every time they do a load of laundry, and then they switch to a new high efficiency front loader type of washer. They'll still use the same amount, not realizing that much less soap is being is required in order to wash your load and get all the dirt out. Now, the manufacturers do address this in pretty much every single owner's manual that I've ever seen that comes with a new appliance. But more often than not, the problem isn't that the manufacturers aren't making people aware. It's that people aren't reading their owner's manuals. Does that answer it?
Yeah, that's actually really interesting. Great questions, guys. Okay, I got another one. If a person doesn't respond to a product recall, does that affect subro opportunities? How does the manufacturer have to make consumers aware of a recall? Let's pass the mic to Mina.
That's a good question, George. No, I would say that if somebody's not subscribed, like product registration is not mandatory. It's encouraged, but it's not mandatory. So if you're not subscribed, that's unfortunate, but I've never seen that being held against somebody in terms of a subrogation potential in my experience. I think it's a matter of somebody not tuning into the news at the right time, or maybe not being tech savvy and not being on the internet and getting that exposure to recalls. So the manufacturers do their best to try to reach out to people that they know that have their products, but if they're not registered, it can be very difficult to do that.
Okay, another question. Actually, we have several questions about induction stovetops. So how common are induction stovetops, and how does an induction top range surface work, and does it cause fires? Let's have Mina speak to that.
That's a complicated question.
That's a great question. So to answer your question, no, they're not common in terms of fire causation or recalls. They basically work by using a specific type of pot that responds to the induction heating. So you have to be cooking in the right pot for it to actually heat the food. They're great for safety for burns because they're cool to the touch. So if you put your hand to the element that's on, you won't get burned. So that's a great safety feature in terms of accidental activation, or if the controls fail, it won't actually start a fire. But the same hazards do exist with unattended cooking fires with the induction stove. So they are a little bit safer, and we haven't encountered any recalls with them or any products just yet. But as they become more popular, that can be coming in the future.
Another question came in: are induction elements less commonly a problem for cooktop fires? And I guess you've answered that saying yes, they are less common. Is that right?
Yeah, because one of the reasons they're less common is because they're less prevalent out there on the market. So less people actually buy them. But like I said, if you've got the right pot and you've got the right fuel in the pot, if you're making French fries and you leave the pot of oil, it works just the same way. It's still going to overheat the oil. It's still going to ignite.
All right. Are you seeing losses with dehumidifiers that drain constantly so they don't shut off and overheat?
I would say the leading cause of dehumidifier fires are problems with circuitry. So electronic circuit boards, electrical connections that are improperly manufactured, and sometimes also you can get deposits of minerals depending on where you live. If your water's got a lot of minerals in it, you can get those deposited on circuit boards and cause problems. And there have been quite a bit of dehumidifiers that have been recalled over the years recently. But the mechanism you listed, I'm not entirely familiar with.
Next question: what percentage of fires or floods result from the home builder or owner cutting corners, for example, not using CSA approved pipe? Michelle?
I honestly can't answer that question in terms of percentage. Let's see that question again. Where is it? What percentage of
fires or floods result from the home builder or owner cutting corners?
I can tell you from my experience in the last 13 years that it is really rare that I have had any involvement in a file that is related to the builder not following code. So Mina, I don't know if you would have anything different to add. Yeah, Mina's in agreement with me. So I have had some instances where home builders have subbed out installations of sump pumps to the local plumber, but that's very common. And none of the sump pumps that I've done, for example, that were in new builds failed as a result of how they were installed. They failed as a result of a manufacturing defect, in fact.
Great. Thank you very much, Michelle. So we'll answer the rest of the questions. These are really great questions, and thank you so much for submitting them. We'll make sure that we get to all of your questions personally. So if you've submitted a question we haven't got to you yet, we promise we will respond. I'll make sure that Michelle or Mina touch base with you. And you have all their contact information as well. I'll show it at the very end of the presentation. I just want to let you know that the webinar was recorded and will be posted on our web page, on our website, on LinkedIn, and on YouTube pages. So please feel free to pass them on to your colleagues or use them in your team meetings if you wish. We'll be sending each of you a completion certificate in a follow-up email within the next couple of days. So for those who are not signed into the webinar under their own name but are attending within a group, please email me at webinar@origin-and-cause.com. You can see that right on your screen at the bottom of the screen. If you're within a group but you have signed up, I wouldn't be able to know that. You need to make me aware of that, and I'll make sure that I make up a completion certificate for you and send it. As soon as the webinar ends, there's going to be a window that pops up on your screen asking you 6 feedback questions. This is really important. We put a lot of passion and heart into these presentations, so we'd love to hear feedback from you just to find out how we can improve for future webinars. I just want to go very quickly over who Origin and Cause is, in case you guys are not very familiar with us. So quick fact is we've been in business for 24 years. We're the largest forensic engineering and fire investigation firm in Canada with 10 locations across Canada with over 25 experts. We have offices in Ancaster, Mississauga, Kingston, Ottawa, Sudbury, London, Windsor, Halifax, Winnipeg, and Calgary. Our services include fire and investigation explosion. We have a K9 unit, which is really cool. On the picture on the right here, you can see Smoke, who is an accelerant detection dog. We have structural engineering services as well. Electrical engineering, which Mina is part of the unit as well. And alarm system analysis. This is Mazen Habash, who is the president of the organization, taking a look at an alarm system. We have a mechanical engineering unit, and that's actually Michelle Bradley there. Materials and metallurgical engineering. This is Dino Matei, the one that lights up when he talks about solenoid valves. I'm not sure what he's looking at there. He's like a gear clamp or something. We have a chemical engineering unit as well. I encourage you to take a look at our website. We've got a lot of great resources. So it's origin-and-cause.com. I'm really excited to announce to you the next webinar that's going to be taking place on November 24th. It's titled Ask an Expert, Open Mic Discussions with Leading Forensic Engineers. If you have any questions that you've always wanted to ask a forensic expert, or if you'd like to hear questions your peers are asking, make sure you sign up for this free webinar. It's just a chance to pick the brains of some of the most sought after forensic engineers in Canada. We have obviously experts from Origin and Cause, and we're happy to have COTSI Forensic Engineering featured with us to represent accident reconstruction and having a biomechanist as well to join us. So the panelists that are going to be included as forensic experts in this kind of Q&A open discussion is Mazen Habash, who's the president of Origin and Cause and specializes in fire investigations and electrical and electronic failures, product liability, and alarm system analysis. Dinu Matei, who's our materials and metallurgical engineer. Brian James, who is also a mechanical engineer with a lot of focus on vehicles. Yasser Karani, who specializes in structural forensic investigations. Sam Kotze, who is the president of Kotze Forensic Engineering and Consulting, and he is a accident reconstructionist. And Brett Campbell, who is a biomechanist and accident reconstructionist at Kotze Forensic Engineering. So we're really excited about that. So make sure that you sign up. Actually, one of the 6 questions that are being asked in the questionnaire that's going to pop up is, do you want to sign up for the next webinar? So just hit yes, and we'll make sure that we got you signed up and we secure a spot for you. Thank you again, everyone. Thank you so much for your time. We really love, speaking to our clients and teaching you guys, because it really does help us at the end of the day as well. Knowing that, knowing this information helps you, of course, with your claims, and ultimately we're happy when we're able to help you guys. You have Michelle's contact information there and Mina's contact information. Thank you very much, and have a great day.